So it says use the unit circle, and that's key. Right? If it didn't tell you use the unit circle, like that makes things a little bit trickier. But it specifically says use the unit circle. To determine the exact value, that's also key. When I see exact value, that typically is telling me like use the unit circle. Typically, not always, but it's a good hint. I'm like, oh, okay, this is unit circle stuff. Use the unit circle to determine the exact value for each trigonomic ratio. Okay. Sine means y over r. R is 1 because it's the unit circle. So sine really just means the y value at 3 pi over 4. That's what it's asking you to do. You'd go to your unit circle, you'd find 3 pi over 4. 3 pi over 4 is here. The y value is root 2 over 2. This thing is root 2 over 2. Cool. If you look at B, B is tan of negative 120 degrees. Tan's the hardest one. Tan means y divided by x at negative 120 degrees. If you don't like negatives, you could make it positive by adding a spin to it. And that would get you to the same point, right? That's coterminal. So negative 120 degrees plus 360 degrees is the same thing as saying 240 degrees. Negative 120 and 240 will have the same x and y values. It's at the same point. So if you hate negative angles and you're like, I just can't visualize where that goes, that's fine. Make things positive by adding spins to it. And then you can figure out where it is. On your unit circle, 240 degrees would be 180 plus 60. This would be 240 degrees. That point would be the same as all the other root 3s, or sorry, divided by 3s, but with a negative x and a negative y. So this point is negative 1/2, comma, negative root 3 over 2. Tan is y over x, so that'd be negative root 3 over 2 divided by negative root 3 over 2 divided by negative 1/2. You could write it as a fraction over a fraction. I don't got enough space for that. Kiss and flip it. Right, make it multiplication. Flip the second fraction. This is negative root 3 over 2 times negative 2 over 1. The negatives will cancel. The 2's will cancel. It's it's root 3. Ooh, the internet has gone back to not good. So if you're hoping to watch this video, it might not work. We okay with that? Yeah. Cosecant? What is cosecant? Cosecant is 1 over sine. Perfect. So what we did was we would find sine and then flip the fraction. And that'll give you cosecant. So go and find what sine of pi is. Sine means y value. Pi is on your unit circle. It's often one we forget. It's over here. The y value over there is 0. Right? It's negative 1 to the left and 0 because there's no height. That means sine, the y value, is 0. So this is 1 over 0. I think. So like I get the idea of normally what we would do is we'd flip the fraction. Right? We would just be like, oh, it's 0 over 1, which actually is something you can calculate. But cosecant is 1 over sine, which means it is 1 over 0, which is not allowed. So that is undefined. Because you can't divide by 0. That's a tricky one. Perfect. Up here. Cos of 11 pi over 6. Cos normally is x over r. Because it's the unit circle, r is 1. That means this is x value at 11 pi over 6. You go to your unit circle. You look for 11 pi over 6. It's over here. That's 11 pi over 6. That's the same as the other pi over 6. But it's reflected down, so the y value is negative. This point would be root 3 over 2, negative 1/2. The x value is root 3 over 2. Good? Okay, if you look at E, 7 pi over 6 is on your unit circle. You're looking for the x value at 7 pi over 6. That'd be negative root 3 over 2. And cosecant of negative 240. I would change cosecant to 1 over sine again. And also, because I don't really like negative angles, I would add 360 degrees so that I have a positive coterminal angle, and it'll still get me the same answer. So this is sine at 120 degrees. So 1 over sine of 120 degrees. 120 degrees is up here. The y value is root 3 over 2. Nope. There we go. So if I want 1 over sine, that would be 2 over root 3. What's wrong with that answer? Can't have a radical on the bottom, so we have to rationalize our denominator. We have to multiply root 3 to the top and the bottom. On the top, that is just 2 root 3. On the bottom, that is 3. The answer is 2 root 3 over 3.
Do you have to show that line?
Which line?
Like in between the multiplication of the root 3?
Yes, that line. You have to put a line here when you multiply top and bottom by root 3. You do. Otherwise, you have to create something that's mathematically even real. So you do have to put a line underneath there to show that you're multiplying by a fraction, root 3 over root 3, which is 1. No, no. You do great. Okay.
I probably won't even put the multiply thing. My answer will just turn up.
Yeah, just turn it up. Okay, number 2. Determine theta in standard position. In standard position. Round answers to the nearest tenth of a unit. Okay, we have a point here. That point is at negative 3, 4. Negative 3, 4. Come on. Is somewhere up here. We're in the trig unit. Make a triangle out of that thing. The triangle connects to the origin. We then put side lengths of 4 and negative 3. It's a nice one again. Okie dokie. They asked for the angle in standard position. The angle in standard position starts here and goes to there. That's theta. It is not inside the triangle. It's actually outside the triangle in this question.
Can't you just find the angle inside the triangle and subtract it?
It's exactly what you need to do. So your triangle can only solve angles in the triangle. So when you use your triangle, you're going to find this angle, which we're going to call beta. Alpha. That's not beta. It's fish. Beta fish. And then we can use our idea that 180 degrees, sorry, we're doing radians. Notice that the boundaries are in radians. So my answer should be in radians. Okay, so I'm going to do pi radians, subtract my fish, alpha, and that'll give you theta. You'll also notice that it says round to the nearest tenth of a unit, meaning we don't have to have an exact value for our alpha, which I almost called beta again. Cool, calculating alpha. I'm going to do SOHCAHTOA. This is my opposite. This is my adjacent, also known as like your y and your x. So I'm going to go tan of alpha equals opposite, which is 4, over adjacent, which is -3. To find an angle in a triangle, you hit second tan. Also, because it just works better in our calculator, we're going to make those positive values. So it'll be +4 over +3 equals alpha. Sometimes that matters, sometimes it doesn't. Just put positive fractions into your calculator when calculating reference angles.
Why can we make that positive?
Because this triangle would be the same thing as if I was in quadrant 1, which would be the same reference angle.
Oh.
When you do this, you must be in radian mode. If you are in degree mode, you will be getting a degree answer, which we don't want. So make sure you have radian mode highlighted when you hit mode. Now that I know I'm in radian mode, I go second tan. It's 4/3, right?
Yeah.
4/3. It is 0.93 radians. Now I can do my answer. Pi minus 0.93 radians will give me theta.
Does it matter if you use tan or could you use something else?
If you used any other ratio, you would have had to find the
Okay.
hypotenuse, which is 5, which isn't hard, so you could do any of the other ones. Your answer is 2.21. All right, remember with trig, your answer has to be within the boundaries that they give you. It's why they tag on these little statements to the end of like every question. That tells you a lot. This tells you that you can only do one spin. There's no other answers beyond one rotation. It also tells you that you're answering in radians, not degrees. Right, so these little like tagged on things at the end do matter. Had it not been there, then I would have to do a general solution because I could do multiple spins to get to that point. The general solution would be 2.21 plus 2 pi n.
But would it be 2.2 because it wants it to go to?
Is it to, oh, whatever, yeah. I'll do.
That's fine, I was just making sure.
This would be your general solution. So it's that angle in radians plus however many spins that you want. A full spin is 2 pi. All right, number 3. If the question didn't have boundaries, which is what I was describing, you would have to do that.
But it doesn't.
It does have boundaries, so I would not on a normal question do that.
You would just do that. The answer.
This is the correct answer for the question.
Yeah. But if it didn't have.
But if it asks you for a general solution, you need to do that.
We have the boundary of 4 pi, and it would just be that solution. Plus 2 pi would also be an answer then?
Yeah. So if they gave you these boundaries, 4 pi is 2 spins, I would have 2 answers. I'd have 2.21. That'd be 1 answer. And I would have that plus 2 pi, which would be 8.5. And that would be in my boundaries 0 to 4 pi. Right? It like all kind of depends on that last portion. It's easy to just glance over that last portion. I wouldn't. I would highlight it every single time because that's telling you boundaries. It's telling you where your answer can be. Same thing if it said the boundary was negative 2 pi. Right? And now I could do a negative spin. So I would have to then subtract a spin to get the other answer.
How many spins is the 8.5?
That's just adding 2 pi, right?
Yeah, I just added 2 pi. I just added 1 spin to it. Yeah.
Okay.
All right. Look at this guy. If cos of A equals root 3 over 2, and A is in between 0 and 90 degrees, so I know I'm in the first quadrant. Right? That's what this says. That says first quad. And B equals 60 degrees plus A, then the value of secant B is. My goal, my end goal, is to calculate secant of B. Secant of B is my end goal. I know that secant is 1 over cos. So I'm going to have to figure out 1 of cos B. All right, B. Let's backtrack a little bit. B equals that, 60 plus A. A comes from this guy. So if I'm backtracking all the way to, I want to figure out what B is. It's 60 degrees plus A. Then I need to figure out what A is. And I can backtrack all the way through this question. What is A? Well, cos of A equals root 3 over 2. That means the x value at angle A is root 3 over 2. If you look at your unit circle, x value of root 3 over 2 happens at 30 degrees. That means A equals 30 degrees. That's the angle that gives you an x value of root 3 over 2. This means that B is 60 plus A. So B equals 60 degrees plus 30 degrees. B is 90 degrees. Now, I can go ahead and figure out what 1 over cos of B is. Cos means x value at 90 degrees. If I look at 90 degrees, it's straight up. That has an x value of 0. That means my answer is undefined. I've got to use all this information, right, to figure out the next part, It's like a little puzzle. Are we okay with that? Confusing when you read it, but then the actual work to it's not terrible if you know the path that you need to take. Just finding that path is hard. Okay, number 4. I want to be clear here about number 4. At no point does number 4 ask you to find the angle. Never does it refer to what is the angle of theta? Never. It's telling you ratios, right? Like cos of theta, that means x over r is this. I need to use that ratio to figure out these ratios. Figure out what sine of theta is. Figure out what cos of theta is. I do not need to find the angle. I'm only finding ratios. All right, building our triangle. Do a little sketch here. They said that cos equals this. Oh, that's not a pen. Cos equals this guy. Well, cos is x over r. That means I have an x value of -3 and a radius of 5. That can be built in 2 places. It can be built here. That would have an x value of -3 and an r value of 5. Whoa, this is getting bad. Or I could build this equation here. Both of those have x values of -3 and r values of 5. Remember, r's are always positive. This ratio could have come from either of these triangles. This part of the question tells you which triangle is right. That says that tangent has to be greater than 0. Greater than 0 means positive. So tangent has to be positive. Tangent is y over x. That means that the x value divided by the y value must be positive. Over here, the y value would be positive. So x divided by y, y divided by x would actually be negative. This would not work out. Down here, I have a negative y value. A negative divided by a negative would be a positive. Therefore, tangent would be positive. I know I'm in quadrant 3. Perfect. We need to figure out what sine of theta and cos of theta are. Sine of theta, the ratio sine of theta, is y over r. Use Pythagorean theorem, that y value is -4. I know it's negative because of the quadrant I'm in.
Do they give about the special triangles? Or?
No.
Yeah.
It'll probably be, you'd actually have to do Pythagorean theorem to find it. That means sine of theta is -4 over 5. Cos of theta, we already knew because the question told me what cos of theta was. It's -3 over 5. And now I can answer my question. I need to do -4 over 5 squared minus -3 over 5 squared. Calculating that, that's going to give you 16 over 25 minus 9 over 25. My answer as a fraction would be 7 over, that's a 5. It's just my friend, the internet. The answer would be 7 over 25. That's the exact value of it. If you put it in your calculator, you could get a decimal as well. Yeah, math racket, you're good. One of the biggest mistakes that typically you guys make really simple mistakes. You guys actually know how to do all the hard stuff. And then you make like calculator errors, like really simple things. Make sure you put brackets around your negative. That's a big one. If you don't put brackets around your negative, it actually screws up your calculator. Right? So make sure you have brackets around your fraction when you square it. Okay, number 5. If the value of cotangent A and the value of secant A are both negative, then let's sketch it. Cotangent is 1 over tangent. Tangent's y over x. So you could flip it. Cotangent is x over y. Yep. If cotangent is negative, it's here or here. It means you have one positive, one negative. And that's the only way cotangent is negative. The next one is secant. Secant is cos. Right, it's 1 over cos. Cos is x over r, so secant is r over x. That means x is negative. That means I'm...
Negative radius, right?
Right, you can't have a negative radius. That means I'm either here or here. Those are the two spots where x is negative. The only place that both those things could be negative is this one right here. This is quad 2. They talk about angle A. That means angle A is in quadrant 2. For angle A to be in quadrant 2, that means it must be bigger than pi over 2, because that would be 90 degrees. And it must be less than pi, because that would be the x-axis over there. The answer is B. Notice that it doesn't say equal to pi or equal to pi over 2. It's because if you equaled pi, you start to get 1s and 0s, or 0s and 1s, right? And same with if you equaled pi over 2. And that screws up your ratios, because then you're dividing by zeros and stuff like that. Here comes a graph. Fun. Graphing. Look at that. All the info's there for you. We rarely see tangent graphs, right? Like there's info there for you if you want. I'm definitely going to focus on sines and cosine graphs. Both are sinusoidal. Things to remember. The mother functions. The big thing's the starting point. So on a sine graph, you start at the origin. You then go up to 1. You then come all the way down to -1. And then you go back to the beginning. That's one cycle of a sine graph. It then repeats that cycle infinitely until you hit menopause. Shoot. Cosine got all the males and did not. I was just like, whoof. I've never seen a half a room be so divided. You know? I saw, yeah, it is accurate, right? I did see some smiles, so we had a few who get what I'm talking about. Yeah, all the females laughed.
Process when you said, and I was like, oh yeah.
I see you have a comedian. Teaching on nothing funnier than
I don't get that. Cosine graphs start at 1. So it starts at the maximum. Then it goes all the way down to the minimum of -1. And then it goes up back to the maximum. The starting point matters. Right? That's the key difference between the two. They're the same thing, but one's shifted. Okay, looking at these graphs. Thank you. I have the function y equals a sine b x minus c plus d. You'll notice that b is factored out. Right? So it's b bracket x minus c. All those values tell you different things. The a value is your amplitude. The amplitude is the distance from midline to the max or min. Visually, my midline is right here. So the amplitude is this distance, max to midline, or minimum to midline. Those distances should be the exact same. You saw that struggle? Love our internet. Right, that's your amplitude. Cool. Oh God, why does that say that? The B value is not your period. The B value calculates your period. It is not your period. That's not a good thing to have on there. Yeah. Your period equals 2 pi divided by b. And those are interchangeable. You can switch the period and the b value to calculate each other, right? Like these two things, we cross multiply and divide. So you could also say that b equals 2 pi divided by your period. A reminder that your period is how long it takes for one cycle to be completed. So when you're looking at a graph, your period is this distance from here to there for one cycle. Notice that the graph then starts to repeat itself. So this distance is your period. In this case, that would be 2 pi. Your C value is a phase shift. It's a horizontal shift. It's moving the graph left or right. It's pushing it one way or the other. Visually, that's hard to tell. For our sine and cosine graphs, think about where your starting point is, which is on the midline, and make sure that starting point gets over to the y-axis. Hopefully we get to a question like that. Your D value is a vertical displacement. I don't ever refer to it as that. I mean, technically, that's what it's doing. It's moving your graph up or down. It is a vertical translation. I just always refer to it as your midline. But it is like a vertical shift up or down. Like if I move my midline up to 2, the whole graph moves up. Yeah.
That's two formulas for the A and D value.
So if you want to like memorize formulas for like how to calculate D and how to calculate A, you could. The midline is also called sometimes the average of a graph because you have the same amount above and below. And to calculate averages, you would just take your max plus your min and divide it by 2. And that'll tell you the average of your graph. When I talk about max and mins, I'm talking about y values, right? So maximum y value, minimum y value. Your amplitude is a very similar formula, but it's minus. So you go your max, subtract your min, divided by 2. If for whatever reason you like need to depend on that or something. Okay, that's a breakdown of sine equations. You could do the exact same thing for cosine. So it's A cos B x minus C plus D. It's the exact same thing. Let's look at these. Using the language of transformations, describe how to obtain the graph of each function from the graph y equals sine theta or y equals cos of theta. They're both sine thetas, so I guess we'll do that. Looking at this. I don't know. It's a cool looking theta, but it's just theta. A. Look where it drew my A. That's interesting. Your A is the amplitude. It equals 3 here. That means the distance from the middle to the top should be 3, the amplitude. In terms of transformations, this would be a vertical stretch. Yeah, don't put VS. I just don't know how well my computer's going to hold up anymore. Vertical stretch about the x-axis with a factor of 3. I always make a good debauchery of that sentence. Keywords you need to have. You have to say vertical stretch, not VS. You do have to say about x-axis somewhere in your sentence. And you need to say factor of 3 somewhere in your sentence.
What if you had like the wrong order?
With a factor of 3, of a factor of 3, in a factor of 3.
You can say vertical stretch by a factor of 3 above the
Perfect.
x-axis.
Yep, by a factor of 3. As long as you say factor of 3, x-axis, vertical stretch, you're going to be golden.
Kind of doesn't really matter.
Yeah. By a factor of 3 is a much nicer wording. Like I said, I make a debauchery of it every single time. 2. This is your B value. That is not your period. The period is not 2. The period for that would be pi, because 2 pi divided by 2 would be pi. The 2's would cancel. The B value is a horizontal stretch. I don't have time to write at a slow pace. So it's a horizontal stretch by a factor of What's the factor of 1/2? Remember that our horizontal stretches are 1 over what you see. About the y-axis. I'm just putting about y-axis. This thing is falling apart quickly. Your C value. Yep.
Only when you're writing the B value is that when you flip it and put a 1.
Yeah. So the B value is 2. It is a factor of 1/2. So when you describe it, it's 1/2. If you are actually applying it, it's 1/2.
Okay.
But when you put it into here, it's 2. When you're in transformation notation.
So if it was applying it to a point, you'd multiply by
1/2. Yes.
And if you're given it in the equation, then it stays as that value.
Yeah. Like it's 2 in the equation.
No, but like if it was like not an actual equation, but just in like the question, like in a sentence.
Yeah. So if they had said the B value is 2, I would put it 2 here. And then be a factor of 1/2. But if it said it was stretched by a factor of 2, then the B value would have been 1/2. Yes. Whenever you see factor and B value, those are the opposites of each other.
So B value is the opposite, but if it's a stretch, it's what's in the
That's the actual factor. Yeah. Your C value here is pi over 3. That's a horizontal translation. You need to write horizontal translation, not HT. You will not get marks for HT on your diploma. Horizontal translation, pi over 3 units. And then say if it's left or right.
Do you have to say units for the diploma?
You should. Does this thing go left or right?
So are we not calling them phase shifts and displacements?
No, you're fine. If you said a horizontal,
That'd be wrong.
yeah, no, you'd be fine. If you said a horizontal phase shift, that means horizontal translation. So you'd be fine.
They do the same thing.
Yeah. Left or right? Right. And my D value. My D value is 6. That is a vertical translation. Actually, before I even say that, that's your midline. That means the middle of your graph's at 6. Vertical translation, 6 units up. Wait, no, I'm stopping the video for now.